So thank you for coming to the dev room of Internet of Things. I'd like to present our next speaker, who's Nikos Keflakis from Greece. And Nikos is a researcher in a number of areas, especially European projects for RFID and OpenIoT, which is the project for the Internet of Things, one of many projects. Nikos, we have 15 minutes for presentations, 10 minutes for discussions, and then we cut. And if people ask questions, please repeat the questions because we are streaming live to the whole world, and it's through the microphone here that we hear. So if you're talking, we won't hear you. Keep your questions short, clean. Nikos will repeat them for the camera and for the audience. Thank you very much.
Okay, thank you very much for the introduction. And thank you for joining this session. In this session, I'm going to present you the OpenIoT project, which is a joint effort of 7 European partners, universities, and industry, and it is part of an EU project. So, what can OpenIoT do? First of all, the OpenIoT is a mean to capture data from various sensors. And when we say sensors, we mean virtually anything. So this room could be a sensor that has some observation as attributes. So, for example, the number of people that are here now attending this meeting could be an observation item that could be captured from this platform. After pushing this data to the cloud, this sensor data to the cloud, we are able to discover the available sensor types that consist this data. And these types then can be used with an appropriate user interface that we have built to create easily and without considering the complexity of the middleware, the platform, and the technologies, services that could be used later on from a user, simple or more complex. Then we can visualize these services that have been built and create mashups and provide them to either to the public or for private use. And finally, we can manage these resources, and we can the modules resources and our platform deployment, and we can apply optimization in various stages of this platform. So what can you see here is a high-level description of the OpenIoT architecture. So as I have described before, we have our sensor middleware platform, which is in fact our legacy from another open source project called Global Sensor Middleware, the GSN project, which we have extended to support the cloud storage and semantics and to semantically annotate the data and store them to a cloud platform. So then we have our cloud platform, which can run either locally inside a campus, inside a company, or be public. So for the example I will going to give you next for the demonstration is run to the EC2 Amazon cloud. Then it is consisted from the scheduler, which is responsible to discover available sensors and help the request definition tool to build and store a service description to the data cloud. And then we have the service delivery utility manager, which then undertakes the task to retrieve these descriptions and visualize them at the request presentation module. So, as I have already mentioned, with our platform we can create a virtual sensor out of anything in our everyday lives, or physical or virtual one, and it doesn't take more than one or two mandates to create it, because we have implemented a special interface. We have created a special interface that someone has to implement and use all the available features provided by the global sensor middleware platform. Then we have, it has the ability to annotate this data and semantically annotate this data and store them to the cloud. And of course, we have tools to facilitate this deployment. So another thing that we can do, as already mentioned, is the sensor discovery and the ability to use these sensors to create new services and store them back to the cloud. These services are described with Sparkle queries, so we are using the Sparkle query language to store and retrieve this kind of data. So, and then of course we have visual tools to help this service description, where with a toolbox and just drag and dropping modules, it is possible to automatically create and transparently from the user to create the required Sparkle queries to be used later in our service visualization. And of course, we have the tools. We already have created some widgets, line charts, pie charts, gauge meters, or maps that the data that are retrieved from our platform can be visualized, but it is also easy, as we are using open source libraries to do that, to create new widgets that can apply to other. Compare the wind chill temperature versus the actual air temperature in Brussels area for the last 3 weeks. And so this service will be done on the fly and without having priorly set up anything else. And of course, this is going to present it with the widgets available in the request presentation tool. Okay, sorry. So as you can see here, we have integrated all our tools in a simple point of entrance, so the OpenIoT IDE tool. And now we have started creating our application. So we just enter a new name, a new application name, and we start configuring our scenario. So the first thing we have to do is go to the Brussels area and check for the available sensors. So we pinpoint an area, and we set a radius of 15 kilometers. So our point of interest is this specific area. And now we have discovered 2 available sensor types, and one of them is the weather station. So we need to apply a filtering mechanism from our toolbox to define the dates that are of interest of us. So we define the 3 last weeks, actually the 3 last weeks when this video was taken. So from 7th till the 28th of January. So you're going to see the actual temperature of Brussels area for this for these 3 weeks. The next thing, we apply and compare. Sorry, a group modules so as to group the wind chill and the air temperature by year, month, and date. So after we have set up the group mechanisms, we choose the average from our toolbox as an aggregator. So because we want to get the average for every day. and we're going to use a line chart as a sink. So at the line chart, we choose to provide two lines because we're going to have two inputs. And at the x-axis, we're going to set up the date, so a date observation, and at the y-axis, we are going to set up the Celsius value. So after setting up the line chart, we just connecting the appropriate outputs and inputs to the line chart. So we connect the dates at the x-axis and the average output at the y-axis. So the next thing that we have to do is we can validate this design. So we actually can automatically generate the Sparkle queries that are involved in this design. So if you take this Sparkle query and execute them at the Sparkle interface of an RDF data store, they can produce the output that we are going to visualize later. So all this information together with what kind of widget we are using, some constraints that we are using, and the structure of the service are sent to the scheduler and are stored to the cloud. And so now, by logging in at the request presentation tool, we are retrieving this information. So now it loads the application setup that we have already done. And now we are going to visualize it. So after refreshing the tool, we can see at the widget the actual temperature value. So I guess it was a little bit hotter in the 3 weeks of January than now. Didn't finish. Okay, but I didn't finish. Yes, but yes, you did.
So the question was, you're showing a weather capability, and on the filter on the input you put a date. How did I know, for example, that was a date capability and not, for example, altitude or geographical area? What talks about the capabilities there?
Thank you. For this specific tool, this specific box module, if you noticed, it's referring specifically about date. So it wasn't something else. So currently at the filtering part, we support dates, but later on we can extend it for other metadata of sensors. For example, the depth that a sensor is put in the ground, if we want to count ground humidity or other values that have been supported. So we are a relatively new project. So. Okay, so to go to the open source part of the thing, we are using LGPL license version 3. Our project was first released at September of 2013. All the modules provide Maven management, and we have documentation available in our wiki for Eclipse and NetBeans IDs. We have the open source project portal, which is available at GitHub. So it's the OpenIoT project. We provided the wiki again from GitHub. The documentation inside, you can find the documentation inside the wiki. We have the download links, and also you can find the project stats in the OLOG. So we are using for our project other open source libraries, containers, and frameworks. So we are using the Apache Maven already mentioned. Our preferred integrated development environment is Eclipse. We're using JBoss REST Easy for the web services. We're using JSF prime phases and JS Plum for the user interface that have been demonstrated and you have already saw. JMX and Java Melody for the management and monitoring. Our web container application platform container is JBoss. For the RDF database, we are using Virtuoso, the open source version of Virtuoso, Sesame and Jena libraries for accessing the Sparkle interface that we have implemented. Jasig CAS, that is the authentication system implementation that we're going to have been already implemented in our project, but it's to be integrated to it. And we're using Logbag for processing logging events. So these are some of the open source libraries and platforms that our project is using. Although we are a relatively new project, we have so far 13 contributors, dedicated contributors to it. Our project is mostly written in Java, and although it is a new project, it is one of the best new projects for year 2013. As mentioned, yes, as given from the Black Duck organization, which is the organization behind the OLOG. So our project can be also accessed from our European project link, where you can go to the OpenIoT EU, and we have a more generic view of our site and a more dedicated for academics that you can find the link inside the main site. So if you have any questions, this time I'm going to give some pens since to the ones that already have questions. Thank you. Okay.
So you've talked mainly about logging sensor data. Is your project also about actuating actuators? For example, could it be used in an industrial environment to monitor a process and even control parts of it?
Thanks. Okay. Actually, our project is already been used in industrial scenarios because there are 5 scenarios that implement in the specific project, and actually one is in industry where it is. So the example was only provided as an example. You can have as input anything you like. The one that you cannot do is provide control over the sensor, because we decided that okay, someone may allow access to his sensors, but most of the people won't allow. So they want just to push data to the cloud and not allow someone else to log into their systems and have control over their sensors. So we're only pushing data up, but we're not pushing data down. We have managed another solution about this, which is actually for the sensor middleware to check in a stable time interval if something have changed, if I'm not using a sensor anymore, so it can stop producing data, and so on and so forth. So this is the solution that we have designed and implementing.
Can you justify the fact that you use RDF triple store for storing the data? Because if I had to load a lot of data and then having a lot of throughput, and afterward letting application writing some kind of queries, data mining, machine learning on the data, well, I'm not sure triple store will be the the best choice. Can you explain why did you go in that way?
Thank you. The reason that we have used RDF is that we are using a special ontology that we call OpenIoT ontology, which is actually an extension of the sensor network ontology. This is used to model all the available sensors and sensor types in a manner that we can homogeneously access. So, for example, at Xively, you push data without some specific control. So, all the sensors cannot be grouped. So, by using this specific platform, without the user has to bother on annotating this data with the OpenIoT ontology or bothering about RDF triple store, they can produce their data in a way that can be used from other services and other users. So this is mainly the reason that we have followed the RDF triple store and the specific ontology.
Sorry. I think the reason of using RDF is more obvious because at the moment we are not working only with hardware. We are also working with virtual sensors. So at the time that we have Twitter, we have streams collecting from the internet. So that data is coming in a specific format, which is HTML. So the reason is already the format is there, the standard is there, W3C standard is the format, RDF. So why not to use this standard to bring all the data from Arduino cards or interconnected devices into that format? Then in that way we can combine both. It's true that RDF gives us a little bit of headache when you want to access database. But it's true as well that MySQL is a relational database, and if you have multiple devices, thousands of devices, will have a headache as well. So what we have done, and we are doing at the moment in this project, is extended to stream data processing, which is one of the areas that we are researching, and we're inviting people to do research on that or work with us on that. Because stream processing means we can do queries into streams in real time. So it means we can get information more easily. So we have run experiments, and stream processing queries or stream processing is more efficient than even relational databases. So it's a trade-off essentially in the time.
If you want to look at them, you should sort of. I work with a number of things in finance where they are doing real-time data processing, things like KDB and so on, and it might just be worth looking at those tools because they do it all the time already, sub-microsecond response right now. You know, that's not research, that's everyday business as usual.
Thank you. One more question? Or? Okay.
So we finish at 5 minutes before half hour. We have time this afternoon for participant-driven discussions. So if you have questions about such things as storing data in latency situations, come back with that. Efkaristo, Nikos, thank you very much. That was great, everyone. A round of applause. We have a 5-minute break, and then we start on the hour with the next topic. Thank you very much.